So here's your first introduction to limnology, the study of fresh water. So this is Biology 450, limnology. So this is our Earth, the water planet, as some say. And you can see that most of it is covered by water. We often say 2/3, 70%, something like that, with the rest of it being land. And most of this water is salt water. There's a very small amount relative to the salt water of fresh water. So we need to take good care of that fresh water and make sure it's clean and potable and that it's useful for us and for wildlife, other organisms on the planet. Here's the water planet. A little video. You can take a look at this. It's shot from the SeaWift satellite. So if you click the link there, you can start this. So what is limnology? Well, if you go to this website, you can get a definition of limnology, but it's basically going to be the study of fresh waters. And that's the American Society of Limnology and Oceanography website. It's kind of the premier organization and the journal called Limnology and Oceanography for the field. Limni comes from a Greek word which means pool, lake, swamp, something like that. So what we're talking about is the study of fresh water, or often saline waters, that are within the continental boundaries. So not the ocean, but waters within continental boundaries. So we have lakes, ponds, reservoirs, streams, rivers, wetlands, estuaries, and even microhabitats like caves and holes in trees that a limnologist might study. Now we have lotic, L-O-T-I-C environments, which are the running water, and we have lentic, which are the standing waters. And this is the definition that was promoted by the International Society of Limnology. Strictly, limnology would be the study of lakes, but limnologists also work on rivers and streams and other types of environments. So what's a lake? Well, it's kind of a large body of water, and this is really gray, is how big does it need to be, but we think of it as being maybe deeper than 3 meters with an area somewhere, say from 1 to 10 hectares. Now notice a hectare is about 2.5 acres. These lakes can show, or often show, thermal stratification, depends on what part of the world they're found in. Now shallow water bodies can also be called lakes if they're very large. So for example, Lake Chad in Africa is not very deep, but it can be very large. A pond we think of as a smaller body with something less than 1 to 10 hectares. It's often so shallow that we may not have thermal stratification. Ephemeral ponds are also in the realm of limnology, and these are temporary ponds. Ephemeroptera are the moths and butterflies that have the short lifespan. And that's where that term comes from the Greek. So pools, pans, playas are also figured in here. We can have sinkholes in karst regions, that's limestone subsoil, and so the action of the rain and the water will erode the limestone and it'll sink. So you might have heard of sinkholes occurring in Florida and other parts of the country with a lot of limestone. A mere is a term, I guess that's from the French, for small lakes and ponds. A saltern is a pond that you use in salt production. So you'll run some salty water into this pond, you'll let it evaporate, and you'll collect the salt. So here's a pond in a area that receives a good amount of rainfall. Looks like it's probably toward the north. Here's a pond in an arid area, so this sort of looks kind of deserty. You can see mountains in the background. So this is somewhere in the western United States. Here's a pond, and notice we've have a little walkway constructed across it. This would be what we call a stock tank, or a tank here. It's created by a dam. Here's a pond in a wooded area, small pond. These are playas. So these are actually little depressions that are created by wind erosion. And if and when it rains, then water will collect in these. So you find a lot of these out in West Texas, playa lakes. This is a reservoir. So here we've taken stream and we put a dam on it. And so the water follows the pattern of the stream. So Lake Patman and Lake Millwood are two examples of reservoirs. And so we've created an artificial lake. Now, the difference between a natural lake is this dam can let water out as needed, unlike a natural lake, which usually doesn't have an outflow, but can. Flowing water, we have springs, streams of various kinds. These would flow when there was a rain. For streams, we use all kinds of different terms. So in the South, we tend to use creek, at least in Texas. Some places use creek, up in Kentucky, places like that. Branch, rivulets, trace. A brook would be probably a term they use in the North. If they're bigger, we call them rivers. We can also have pools and streams in caves underground. Backwaters. Around here we call them oxbows, and that's a cut-off river, as we will see later on. An estuary is where the stream flows into the ocean, or it flows into a lake. That could also be an estuary. So here's some different kinds of ponds. These guys are collecting here. Mostly they're collecting invertebrates using those nets. These guys are on the rim of the Grand Canyon, and you can see a little water down there. The Colorado River flows through here, so it's been cutting down through there a long time. Very important place for geologists to go study, and limnologists can also work there. Here we are in a cave, hole in a tree. So this guy's collecting stuff out of there for analysis. Groundwater can sometimes be studied by limnologists. Usually hydrologists do that, but limnologists can get into that. So we're looking at underground aquifers and things like that. And then oceanography is our saltwater. Here's some important bodies of water in the Western Hemisphere. We've got a lot of them in the United States, as you can see. Your textbook author was at the University of Wisconsin-Madison, so he's going to show a lot of stuff from the state of Wisconsin. Here's some important areas in the Eastern Hemisphere. Even Antarctica, under the ice, has lakes. These guys right here are kind of salty, but they're inside the continents, so we call them lakes, or they're under the purview of limnologists. This is an important lake here in Siberia. Now, about 20% of the fresh water in the world is found in this lake. Another 20% is found in the Great Lakes in the United States. When you study limnology, you kind of you're studying an interdisciplinary science. So we use biology, physics, and chemistry. And usually a limnologist would specialize in one of these areas. So I specialized in biological limnology. You can also have engineering limnologists. So you're concerned with all kinds of things, geology, geography, other things like that. You can get into lake and reservoir management, water pollution control, stream and river protection, artificial wetland construction, fish and wildlife enhancement. So it's really a broad field with a lot of application. Let's look at a little history here. So the father of limnology is considered to be this guy. He kind of coined the term limnology. And he was working in a lake we now call Lake Geneva, but they also call it Lake Léman in the French. He was in Switzerland. And this lake, part of it's in Switzerland and part of it's in France, so we get the different names. So he kind of copped out on his definition here, maybe the oceanography of lakes. So oceanography was kind of already established. Here's Lake Léman. Now, I don't know where the border is, but between Switzerland and France, I think it's somewhere maybe over about here. So you can see the lake, and this is an early map of the lake. And it's right here. It's where this lake is located. Now Switzerland's kind of an interesting country. There's really 4 languages in Switzerland. Kind of this part over in here is French speaking, and then you have German speaking, and then you have Italian speaking, and then there's also a Swiss language, which is sounds kind of Germanic. You can take a look at Lake Geneva by clicking on some of these links. Leeuwenhoek, our old friend from the invention of a microscope, can also maybe be considered a biological limnologist, or the father of that, because he described this algae, Spirogyra, very beautiful algae. He took samples of all kinds of water and studied the seasonal cycles of algae, and he kind of hinted at food chains and other types of things. So we can bring him in as one of the ancestors of modern limnology. DWA is an important guy, a French guy. He started physical limnology, where he measured some waves in some lakes. Saussure discovered the thermal stratification of lakes. Pretty tricky thing to do back in that day with very limited ability to measure temperature. Sir John Leslie looked at light and heat and water temperature and wind and looked to see how they affect lakes. Now he didn't actually take the data himself. James Jardine, a civil engineer, took the data, and Leslie just kind of analyzed it. Muller, Johannes Muller, did some early studies, 1845. Peter Muller, I don't think they're related, observed microcrustaceans, so he was a biological limnologist. The term plankton, which is important, came from the Greek for wandering, and it was first used by Henson in 1887. So we have all kinds of different terms now that incorporate the word plankton. Zooplankton for the animal part, phytoplankton, nanoplankton for tiny ones, net plankton for ones you can catch with a certain size net. Here's some zooplankton. This would be the microcrustacean Daphnia, the water fleas. And you can see this is a very old illustration from 1669. So in 1860s, we began to get a better look at the flowing waters, and Lorenz studied the salt wedge in the River Elbe. Now this is where the river flows into the ocean, and we'll see how that works later on. Meyer and Mebus began to look at water pollution in the Thames, and this is of course the big river that flows through London, and it was really, really polluted at that time, and it began to be a cause for concern. So the British said maybe we better do some things to clean this up. And these guys laid the groundwork for that. In the United States, some early work, Louis Agassiz, who was really a vertebrate biologist who had immigrated from Europe, I believe. And he was either at Yale or Harvard. But anyway, he studied Lake Superior, and mostly he was looking at the fish. Okay. And in 1887, a really important guy, Forbes, he described lakes as ecosystems. So he's important in limnology and also in ecology. So he presented this paper, a classic paper in ecology and limnology. The lake is a microcosm, and you can follow that link and read that paper. So there's Forbes. Here's another guy, Burge, an important limnologist. Kind of the real fathers of limnology in North America are these two guys, Burge and Judet. They were at the University of Wisconsin-Madison, and so they worked on those Wisconsin lakes. So the author of your book follows in a long tradition. Unfortunately, the author of your book has passed away, so there won't be any new editions, I guess, unless somebody takes that over. So this might be the last time I use the book. Kofoid did a lot of work on the Illinois River, Needham on New York lakes. The first American textbook was published in 1935 by Paul Welch. There was a German textbook already published by a fellow by the name of Rutner. The classic work in limnology is probably this right here, the first volume published in 1957 by G.E. Hutchinson, who was at Yale University. And he published these massive volumes, the Treatise of Limnology. And he started with, I think he started with, I don't remember which one he started with. But he had one on biology, he had one on chemistry, he had one on physics, and then he published another one, I think it was on the benthos. In 1975, we have kind of a more modern textbook, Wetzel, was published. There's George Evelyn Hutchinson, a really important guy in ecology and in limnology. You can see the importance of Hutchinson here when you look at kind of his academic family tree. So we can see kind of the main part of the tree, the root and the main shoot show G.E. Hutchinson. And then these branches show his graduate students. So for example, W.T. Edmondson is an important limnologist. Now, a lot of these people are, of course, deceased by now. So you can see Hutchinson, and then you can see offshoots of Hutchinson. And there's your author of your textbook right there. So these guys are very, have done a lot of work. So these were doctoral students that we have here. MacArthur, very important in ecology, a number of them. So you might study that a little bit. That was published, I believe, in the first issue of Limnology and Oceanography, which was kind of a tribute to Hutchinson. In running water, an important guy is Hines. He's from Canada. So he published a seminal book called Ecology of Running Waters. In 1975, we had another textbook, Cole, which I have used in the past. This kind of another important event is the Secchi disc, however you'd like to pronounce it. A Jesuit priest by Pietro and Angelo Secchi developed this little device, and it's a very important device in limnology. It's very simple, low tech, but it gives you a lot of information. You use it to measure the transparency of how light is penetrating in the water. And he was on a ship of the Papal Navy. I bet you didn't know that the Pope had a navy. Well, back then he did, 1865. And he was measuring the transparency of water in the Mediterranean the coastal Mediterranean. Other kinds of things that are important was loss of wetlands. We have a tremendous loss of wetlands in the United States. We know these are important for wildlife and other types of processes in nature. So something we need to stop and try to redevelop wetlands whenever possible. Artificial wetlands are becoming more popular for treatment of sewage. We've got dams, so that created these reservoirs for study. And dams also create a lot of problems. In the 1970s, limnology became very important because we saw the advent of cultural eutrophication. In fact, I have an old book on my shelves with that title. The problem really came to a head in Lake Erie when we noticed Lake Erie began to die. And I can remember the Cuyahoga River, which flows through Cleveland, caught on fire one year. And so it really brought it to the forefront. And then all kinds of laws were enacted in Congress. EPA was established and things like that. Basically, what this refers to is the addition of nitrogen and phosphorus to the water, which causes algae to grow like crazy. When the algae die, use up all the oxygen, and then the fish die. So it's a very important development in the history of dealing with water. After that time, the limnologists were asked to produce environmental impact statements when you're going to do a new project involving the water. So you had to try to predict what might happen if you built a dam or something like that. Modeling has become very important in limnology, and so we developed models of different kinds. A model is just a simplified representation. It can be descriptive, or we want modern models to actually be predictive too. A model can assume any kind of shape. It can be a physical model. So if you go to Memphis, I believe it's on Mud Island, there's a model of the Mississippi River ecosystem. So it's an actual physical thing. You can have a graphical type of model, a number of types of those. You can have mathematical models, which you do those on a computer. And you try to predict what might happen if you change some variable. So here's a graphical model of Bear Island. This is the nitrogen cycle. So here's nitrogen coming into the environment. So they're kind of just tracing it through the environment. So this nitrogen gets taken up and then it gets used, and then the critters eat each other. So you have a food web here. Here's another kind of a food web. So this is just kind of a generalized model, a graphical model for what might happen. So the nutrients come in, these organisms use the nutrients, and then the microcrustaceans eat them, and the rotifers eat them, and then other things eat other things, and finally you move up to the top of the food web where you have your top predators, in this case an eagle, and this guy catches a fish. Here's a snapping turtle. Here's a trophic model produced by Lindemann. And so he's trying to show how things move through the system. Here's another trophic model produced by Odom in 1971, Lindemann 1942, in a very important paper, a classic paper in limnology and ecology. Okay, if you want to explore the literature, then these are some of the more important journals, with limnology and oceanography being the most important journal. But you can see a variety of others, so plankton research, freshwater ecology. The Canadians have a really good journal here. The Australians have their own journal. New Zealand has its journal. Hydrobiologia, that's a new European journal. This one right here is an international journal, very good. Excuse me. Sometimes there are regional journals, so Great Lakes Research. The Russians have done a lot of limnology, so they have their journals. The Italians are pretty good in limnology too. Here we have kind of one for the engineers who manage lakes and reservoirs and rivers too. These publish, they're not devoted to limnology, but they publish limnology type research. So a secondary source of information about limnology. We use the regular international units, so centimeters, millimeters, grams, kilograms. We probably need to include milligrams because often we express concentrations of nitrogen or phosphorus, whatever, in terms of milligrams per liter is a common way to express that. Lakes of the world, you might take a look at this, click on this link, and just kind of go through. Gives you a lot of information about some of the lakes. I think this is a website in Japan. Here's a lake in Tasmania, a big island off the southeast coast of Australia. So you can see this lake, mountainous area. So here's Tasmania. I have a niece who's going to move somewhere from Tasmania. She lives, let's see, she lives up here someplace right now, but she's moving. I don't know why. This is a beautiful place up here. Here's a boiling lake in a volcanic area in Dominica. Here's Dominica. You see Puerto Rico here. So Dominica was really wiped out by the hurricane. Which one was that? Was that Maria? I forget. So a lot of these islands really suffered. We know Puerto Rico suffered, the Virgin Islands suffered as a result of the volcano. In fact, we had a couple of students who were going to medical school down here, and they had to evacuate. A couple of our former students. Here we are in Wisconsin. The lake is frozen, Lake Mendota, and so these guys are ice fishing. Now, one of those movies, old movies, Grumpy Old Men or Grumpier Old Men, had some good scenes of people ice fishing there. You might want to watch those. They're real funny. A lot of potty mouth in there, but they're really funny movies. This is Lake Mendota. So that's near Madison. Here's some links to information about our local lakes. So here's Patman. Of course, these are really reservoirs. And then here's Millwoods. These are sites you could follow from the Corps of Engineers. Now, Patman seems to go by multiple names. I think it was originally the Wright Patman Dam and Reservoir or something like that. And now a lot of people call it Lake Texarkana, but it's the same body of water. So those are dammed up streams. And they don't show up too well on this map, but here's Millwood. And then Patman is down here. So this, for example, that's a sulfur river. And then the sulfur flows on down and goes into the Red River eventually. And here you can see the outflow of Millwood also goes into the Red River. All of this is the Red River through here. It goes to Mississippi. These things are oxbows. And sometimes they get cut off and left behind, so there's an oxbow lake. There's Crater Lake. This is one of my top lakes, or maybe my top lake. It's in Oregon. It's in an inactive volcano. I hesitate to say extinct, but it's certainly inactive. It's very, very deep. It has low levels of nutrients because it doesn't have much of a watershed. There's Crater Lake in southern Oregon. So if you get a chance, go there. There's a lodge, probably I don't know. The lodge is probably about right there. It's a national park thing, and you can stay there. So here's looking at it from the top. A secondary eruption produced this Wizard Island. Very low nutrients in this, so there's not much life in it. Now, some idiots put some trout in there a long time ago, but they're really skinny trout because there's no nutrients, so there's really no algae growth, and there's really not much of a food chain. A very beautiful place to visit. Here's Crater Lake in a warmer part of the year. There's actually, the road actually goes all the way around the edge of the caldera. That's Wizard Island in the center. So that is your introduction to limnology.